Hello, it's Bill again, and we're going to talk about gravity, but this time we're going to approach the angle from from entanglement. Now, before we had said that when A and B are entangled, and then someone measures A, then A calls a gravity bit from the cosmic horizon to resolve the spins of A and B. We're going to do a little bit deeper dive. Now, that's correct, but the mechanism how this happens is a little bit more in depth. So what happens is when A and B are entangled, they have to both be in superposition. And you could think of superposition of actually being like a ground state, being zero. Okay, think of positive spin being plus, a down spin being minus, and then you could think of superposition as being zero. So when two particles with spin of zero bump into each other, they can't resolve each other's spins. Yet they are entangled because the energy that was used when they bumped into each other creates a bridge. It creates a bridge between universes. Now remember, on the entropy video, we talked about host particles and guest particles, and how every host is a guest in another host particle's universe, and every host is a guest particle in someone else's universe. So we go back to A and B, and they're both in superposition, and they bump into each other. So since spin can't get resolved, an entanglement bridge occurs between both A's observable universe and B's observable universe. It's a bridge between A's host space and B's host space. Now both A and B, they each have this bridge, but the first one to use the bridge is the one that gets to actually emit the gravity. So this bridge is there. It could be B's measured first, could be A. But let's say A is measured first in this instance. So once A is measured, now that entanglement energy says, okay, A, you had gravity on deck, you go ahead and emit the gravity bit. The gravity bit's emitted that causes the spins of A and B to be correlated. The gravity appears locally. And then this is important. Now this is all on A's horizon, on A's cosmic horizon. A has a copy of B, of guest B, all over its horizon. So guest copies of B also had gravity loaded. But remember that A was the one that emitted the gravity. So B takes that same amount of energy and releases it as Hawking photons. So it's going to be the exact same energy, because what was a gravity bit is now a Hawking photon, because the spin measurement was resolved. The uncertainty of what the spin answer was going to be has been resolved. So you can really think of as entanglement as causing a bridge between two observable universes. And either A or B could use that bridge, but it only has one use. So if B uses it, then host A is out of the picture. Guest A on B's horizon is very much in the picture, and guest A will emit the Hawking photon, and B will emit the gravity bit in that case. So kind of some key points here. We have particles that are in superposition, and think of that as a ground state. It's not +1 or -1, it's at a ground state. So when two ground state spin particles bump, they can't really be one up or one down because they're both ground state. So when A is measured, now they have to correlate B, because now A is going to have an actual spin emerge. And once that spin emerges, then A's counterfactual becomes the gravity bit. And then after that, A's done. It's expended its bits, and it's back in superposition and ready to be entangled again. But then guest B, encoded on A's horizon, is the one that emits the photon relative to A and relative to A's horizon. So these Hawking photons can't be read by any other particle in the universe, because it's only relative to A and A's horizon, because it's A's horizon that lost the Planck area. And this is how everything conserves with gravity. Go ahead and read the comments. Please ask questions and look at my other videos. I have a whole train of this discovery process from the very beginning. And if you have anything to add, please do. I'm always interested to hear new ideas. I've got millions of models running through my head. This happens to be a very well supported, and I have a lot of confidence in this model, but I'm always willing to entertain new models. And leave some comments, and we'll talk to you soon. Bye-bye.